So I just want to address a question that might arise when you're doing factoring. That is, am I always supposed to use the swing method when this number in front right here, which is, we're referring to that as ax squared plus bx plus c, that's standard form. When this number does not equal 1, which it doesn't for each of these, does that mean that I'm automatically supposed to use the swing method? And the answer is no. And I'll tell you, for these two problems that you see on the page right here, one of them needs to involve using the swing method, but the other does not. Okay, and the answer is at number 1, it looks like you would need to take the 3 and swing it, but you don't. And the reason you don't have to is because if you look at these numbers, 3, 6, and 72, they all have what's called the greatest common factor, which we're abbreviating GCF. Okay, greatest common factor just means what's the largest number that goes into all 3. And in this case, the answer is 3. 3 can be divided into each of those numbers evenly. So the way that we would do this is we would pull a 3 out in front. 3r squared divided by 3 is r squared. 6r divided by 3 is 2r. 72 divided by 3 is 24. And now we can do this problem like we've done before. You can see that now the number in front of this squared is just 1. So we don't actually need to use the swing method. So what numbers multiply to negative? Well, it's going to have to be a positive times a negative. And what multiplies to negative 24 but adds to 2? That would be 6 times negative 4, and 6 plus negative 4. Okay, the important thing to note is that you need to keep this 3 in front right here, because if you were to just FOIL what I circled right there without the 3, it would not take you back to the original. So the 3 needs to stay in the final answer. Okay, on the other hand, number 3, you do need to use the swing method, because if you look at 4, 4, and 15, those don't have a common factor. The only number that goes into all those is 1. So you can't do what we did here, which is pull out the 3. So for that, you would swing this over, and 4 times 15 is 60. What kind of numbers multiply to this negative 60? 1 would have to be positive and 1 is negative. And it turns out that the numbers that do what we want them to do, multiply to negative 60, add to negative 4, that's negative 10 times 6. Okay, remember the 4 got swung over here, so we need to get it out by dividing it, because we got it there by multiplying it. Okay, 6 over 4 reduces to 3 over 2, and we'll have to swing that in front. And then 10 over 4 reduces to 5 over 2, and we'll again have to swing that in front. And here's the factored version. You can see, hopefully you see the difference when you need to have a greatest common factor out front versus when you can't have one out in front. Okay, the last example I want to show you is what if you have to do both. So the next case we'll see is where there's both. So if you look at 12, 21, and 6, those all have a common factor of 3. So we could pull a 3 out in front. 12 divided by 3 is 4. 21 divided by 3 is 7. 6 divided by 3 is 2. But now notice 4, 7, and 2, those don't have a common factor. So we need to continue by using the swing method right here, by swinging that over. The 3 still needs to remain in front, because without it we're not going to get back to what we originally started with. So 4 times negative 2 is negative 8. What multiplies to negative 8 but adds to positive 7? So we need a positive and a negative, and it turns out to be plus 8 minus 1. Okay, and then where did the 4 go? It's still buried inside there, so we'll get it out by dividing. So we're going to have 3 times 8 over 4 reduces to 2, and this one needs to be swung in front. Okay, and this right here, this is our final answer. Sorry, that didn't quite work on that circle there. That's our final answer, because we need to have the 3 in front once again to make sure it multiplies back to the original. So hopefully that clarifies when you would use the swing method versus when you don't.